Hello guys, so our last lesson was rational equations. This topic is rational inequalities. Inequalities are the whole greater than, less than thing. And man, look at all these notes. Okay, so there are different ways to learn how to do these. I'm just picking one specific method. I'm going to go with it. I'm not going to vary. I'm not going to fluctuate. I'm just going to show you how it's done. At least a way to get it done that's consistent. All right. Here's what we want. Whenever we solve a rational equation, one side of the inequality must be 0. In some problems, it's set up that way from the very beginning, and that's easy. In others, you got a little work to do to make that happen. We are going to be finding something called critical numbers. You already have done this in other equations, in inequalities before. They just may not have been called critical numbers. So there's two types of critical numbers. There are discontinuities, which we've talked about a lot. That's numbers that make the bottom of a fraction equal 0. And then there are zeros. Essentially, it's what makes the top of a fraction equal 0. Finding zeros is anytime you set something equal to 0 and solve it. Now I know these are inequalities. Sometimes you temporarily set something equal to 0 to solve it, but that doesn't change the original problem, which maybe was a less than or a greater than or whatever. Then, once we have these, we're going to make a number line diagram with those critical numbers, and then we're going to select test points, and from there I'm going to sort of show you what happens. I'm not going to try and write it up in notes. We're going to have to use examples there. Your answer will be in interval notation. So there's two types of notations we went over at the beginning of the year. There's inequality notation, so you could have a final answer that's like, oh, x is less than 3. There's my final answer. That's inequality notation. Interval notation, if you recall, it looked like this. X less than 3 would translate to negative infinity to 3 with a parenthesis. If you had something like x is greater than or equal to 5, that would be bracket 5, comma, infinity. So we're going to be using that notation. It's been several weeks since we've done it. It's coming back. Now, the discontinuities, that's the numbers that make the denominator equal 0. When you put those into interval notation, you always use parentheses. Parentheses are like you're not allowed to actually include the number itself. That's why infinity always has a parenthesis, because you can't ever get to infinity. You can't include it because it just keeps on going. You never include a discontinuity because that makes the fraction undefined, and we're never allowed to have that in mathematics. Zeros, on the other hand, may be brackets or they may be parentheses. If a 0 has an equal sign attached to it, then we use a bracket, like here. And if there is a no equal sign, then you just use parentheses. And again, infinity, always parentheses. Okay, if there's, like, you have no idea what I just talked about, hopefully when I get through the examples, it'll start making sense. So let's look at number 2. First, we need one side to be 0, and it is. That's good. So we are going to find discontinuities in zeros. I'll label this as I go. So discontinuities we find by taking the denominator and setting it equal to 0. X equals negative 7 is a discontinuity. So that is a critical number. Now, the zeros, or 0, you find by setting the numerator equal to 0. Solve that. So we have two critical numbers. Our critical numbers are x equals negative 7, x equals negative 6. You with me so far? I hope so. Now, we are going to take this and make a number line diagram. So let me pick a different color for my number line. How about light blue? And great thing about Notability is it'll snap to a nice straight line. And then our critical numbers are negative 7 and negative 6. So that has to be on the number line. You can throw in some extras if you like, but you don't need to get carried away. Don't go from like negative 10 to positive 10 and all that. Okay, so a critical number, all right, a discontinuity. Let me switch colors again because I feel like it. is going to be circled. It's an important number, but we don't include it because if you plugged in a -7 into the original, -7 plus 7 is undefined, and you can't have that, so you cannot include 7. The -6, since it's a 0, could be a bracket or an open circle. I'm sorry, it could be a closed dot or an open circle. You just got to look at the original problem. There is no equal sign there, so this one is also going to be an open circle. Okay, from here we pick test numbers. We got to pick a test number from this interval, that interval, and that interval, and see what happens. So pick a test number that's less than -7. Well, duh, -8 looks like a great test number. Plug -8 in and see what happens. -8 plus 6, -8 plus 7. That gives us -2 over -1, which is what? +2. So if we plug that in, we get +2 is less than 0. Is +2 less than 0? No. That means that interval is no good. We are not going to shade or color in that interval. Pick a test number from this interval. Unfortunately, we're going to have to do a fraction, so -6.5 or a decimal. And then plug that in and see what happens. So if we plug in -6.5 here, -6.5 here. Well, here's a little tip for you. If you don't really want to do all of the work, you can do this. -6.5 plus 6 is going to be a negative. -6.5 plus 7 is going to be a positive. Positive divided by negative equals a negative. Is a negative less than 0? Yes, it is. So this is a good interval. It's a shaded interval. It's where the answers are. Does that mean it's the only interval? Not necessarily. You still got to cover all your bases. So now pick a test point out of the next interval. So this interval here. Let's try -5 and plug it in. -5 plus 6 is a positive. -5 plus 7 is a positive. Positive divided by positive is positive. Can you have a positive less than 0? No, you can't have a positive less than 0. Therefore, the only answer or answers are between -7 and -6. In interval notation, that's comma or parenthesis -7, comma, -6. And that is the answer. There's the interval of numbers that satisfy the original inequality. But because I've made mistakes before, I'm going to go down and check number 2. Oh, good. There it is. All right. Let's do number 3. Very similar type of a problem. We're going to find the critical numbers starting with discontinuities. Discontinuities set the denominator equal to 0. Add 3 to both sides, x equals 3. Then find the zeros. For that, set the numerator equal to 0. Except my 0 looked like a 6. That would be confusing. Solve for x. What am I doing here? You get x equals a -6. So those are our critical numbers. Our critical numbers are x equals 3, x equals -6. Let's make a number line diagram out of that. +3, -6. So -6 is going to be here. A +3 is going to be here. Now, what about circles and dots and stuff? Well, the discontinuity is always a circle. Can never be a dot. However, this other one, because there is an equal sign in the original problem, that is going to be a dot. Now we need to pick a test number out of each interval. So what can I pick? Let's pick, how about a -7, a number between -6 and 3. Well, there's a bunch of numbers to choose from: 2, 1, 0, -1, -2, -3, -4, -5. I like to pick 0 if I ever get the chance because it's an easy number to work with. And then pick a number out here. Let's go with 4. So there are my test numbers. Maybe I'll try to do this next part a little more better. Let's try 7. So that's going to give us -7 plus 6 over -7 minus 3 is that greater than or equal to 0? That's negative 1 over negative 10. Negative divided by negative is positive. Is a positive greater than or equal to 0? Yes, it is. So this interval gets shaded. I guess I used the highlighter before. Now I'm using the red pen, whatever. Let's try 0. Plug 0 in. 0 plus 6 over 0 minus 3. Is that greater than or equal to 0? Well, that gives me 6 over negative 3. Positive divided by negative is negative. Is a negative greater than or equal to 0? No. So we don't shade in that interval. Now let's try the 4. 4 plus 6 over 4 minus 3. Is that greater than or equal to 0? That gives me 10 over 1. 10 over 1 is 10. Is 10 greater than or equal to 0? Yes, it is. So that gets shaded as well. So my answer is negative infinity to negative 6 bracket union 3 with a parenthesis to infinity. Go down and check it and cross my fingers that I didn't mess anything up. And there it is. One thing I miss about having students in a classroom is when I'm teaching at the board and I mess something up, usually someone will call me out and I won't get too far in making a mistake. All right, so there. These two problems started with 0 on one side of the equal sign. This one doesn't start with 0 on one side of the equal sign, but we want it to. So I need to subtract 2 to move it over to this side of the equal sign. 2x plus 30 over 3x plus 3 minus 2 is greater than or equal to 0. Now, I need to add these together. And that might be something you're not really fond of, but it's not so bad. So here's what we need to do. We basically just need to multiply this by 3x plus 3 over 3x plus 3. 3x plus 3 over 3x plus 3 is 1. You can multiply anything by 1. But what it does is it gives us common denominator. So that's 2x plus 30 over 3x plus 3. Let's see, if I go here, that's going to be minus 6x. Oh, what's the smart way to do this? Here's the smart way to do this. Sorry about this. Since both of these are over the same denominator, I can just go ahead and make this all over 3x plus 3. That's going to save a bunch of writing and prevent me from goofing up. So if I distribute here, I get minus 6x minus 6. And then if I simplify, 2x minus 6x is negative 4x. And positive 30 minus 6 is positive 24. Over 3x plus 3. There. So I had to do all of that just to make this problem look like oh geez, like one of these problems where one side is a 0. So that's why I did all that. Oh joy. Now we can actually, start the problem. So I did a bunch of writing. Let me go over to the right where I got some space. We got the discontinuity. Discontinuity is where you set the denominator equal to 0 and solve it. Divide by 3, x equals negative 1. So there's my discontinuity. To find the 0 or zeros, set the top equal to 0. For this one, not so bad, minus 24. Negative 4x equals negative 24. Divide by negative 4. X equals 6. 6, not 0, 6. So there are my critical numbers, negative 1 and 6. So now I do my number line diagram. Negative 1 and positive 6 have to be on that diagram. I'm going to pick test points, so how about negative 2, 0, and 7. Oh yeah, and don't let me forget, The negative 1 is a discontinuity, so that gets a circle. The 6 is a 0, so that could get a dot or a circle. Since the original problem has no equal sign in it, that's going to be a circle as well. All right, so let me plug these in and see what happens. If I plug negative 2, so what am I looking at? I'm looking right here. Negative 4 times negative 2 plus 24 over 3 times negative 2 plus 3. Is that greater than 0? So what is that? 8 plus 24 is 32. This is negative 6 plus 3 is negative 3. That is going to be a negative number greater than a 0. That cannot happen. So that's bad. We don't want that interval. Let's try the next one. Plug in my test number 0. Negative 4 times 0 plus 24 over 3 times 0 plus 3. Is that greater than 0? Let's see, that's going to be 0 plus 24 over 0 plus 3. 24 over 3. Is that greater than 0? Yes, it is. So that gets shaded in. Make it a little darker. Now let's do the third interval. I'll plug in a 7. Negative 4 times 7 plus 24 over 3 times 7 plus 3. Is that greater than 0? What is that? Negative 28 plus 24 over 21 plus 3. That's going to be negative 4 over 24. Again, a negative greater than 0? No. I should have put a no through there. So the only interval that shaded is right here. And boy, I didn't give myself enough room. Let me write my answer. Where am I going to write the answer? I'm going to take all of this and shrink it down a little bit. Let's say my answer is from negative 1 to 6, and circle that so it stands out. Negative 1 to 6, there it is. Okay, a lot of work. Number 8, very similar. So we need one side to be 0. Negative x minus 9 over 2x plus 10. If I move this over to that side, it's going to become plus 1 greater than or equal to 0. And this I need to multiply by 2x plus 10 over 2x plus 10. So if I put this all together, it's going to all be over 2x plus 10. I have negative x minus 9. If I distribute a 1, that's pretty easy. I get plus 2x plus 10. And then simplify that. So I've got like term here. Negative x plus 2x is positive x. Negative 9 plus 10 is positive 1 over 2x plus 10 greater than or equal to 0. So discontinuity. Oh, no, I'm doing okay. Sorry, confused myself. Discontinuity, set the bottom equal to 0. So 2x equals negative 10, x equals negative 5. That's one critical number. 0, to find the 0, you set the numerator equal to 0. Our numerator is x plus 1. Remember, I'm taking it from down here, not this numerator. So set that equal to 0, minus 1, x equals negative 1. That's my other critical number. Now I need to do my number line diagram. Negative 5, negative 1. The negative 5 is a discontinuity, so it gets a circle. Negative 1, the 0, there is an equal sign in the original problem, so that gets a dot. My test numbers are going to be negative 6, how about negative 2, and 0. So plug those in and work them out. Negative 6 plus 1 over 2 times negative 6 plus 10. Is that greater than or equal to 0? Well, that gives me negative 5 over negative 12 plus 10. Negative 5 over negative 2. Negatives cancel. We get a positive number. Is a positive number greater than 0? Yes, it is. So that gets shaded. Now let's do the same thing with 2. Negative 2 plus 1 over 2 times negative 2 plus 10. Is that greater than or equal to 0? Negative 2 plus 1 is negative 1. 2 times negative 2 is negative 4 plus 10. That gives me negative 1 over 6, which is a negative number. Is negative 1, 6 greater than or equal to 0? No, it is not. So we don't shade in the middle. And do the next interval, the 0. 0 plus 1 over 2 times 0 plus 10. Is that greater than or equal to 0? That gives me 1 over 10. 1/10 is a positive number. It is greater than or equal to 0. So this does get shaded. So negative infinity to negative 5 parenthesis union bracket negative 1 to infinity. Remember that closed dot means bracket. The open circle means parenthesis. That should be the answer for number 8. And there it is. Okay, probably feeling like you're getting the hang of it, but look at number 10. This one's going to be a little more of a challenge, possibly. It's a kind of nice because we do have our one side equal to 0. That cuts out a lot of work, but we have quite the polynomial there. So here's what I'm going to do first. I'm going to go ahead and factor that. That's going to make things a little easier in the long run. So x, 7 times 6 is 42. 7 plus 6 is 13. There we go. So now, when we do our discontinuity, we're supposed to set the bottom equal to 0. It's already factored, so you can just set each factor equal to 0. You get x equals negative 7, x equals negative 6. And then to find the 0 or zeros, you set the numerator equal to 0. And that's pretty easy. X equals negative 8. So now we have 3 critical numbers instead of 2, and they're really close together. So for our number line diagram, we've got negative 8, negative 7, negative 6. Real quick, they're all going to be circles. Discontinuities are always circles. Then the original problem has no equal sign in it, so that means the third one also is going to be a circle. Let's pick some test points. Negative 9 is good. Looks like negative 7.5, negative 6.5, and how about negative 5? All right, this is going to be a little bit of work, but we can do it. Let's plug negative 9 in. That's negative 9 plus 1 over negative 9 plus 7, negative 9 plus 6. Is that greater than 0? Well, here's a way to process this, if it works for you. Negative 9 plus 1 is a negative. Negative 9 plus 7 is a negative. Negative 9 plus 6 is a negative. These two negatives cancel out and make a positive. Negative divided by positive is a negative. Is a negative greater than 0? No. So that does not get shaded in. Let's try that with negative 7.5. So that's negative 7.5 plus 8 over negative 7.5 plus 7, negative 7.5 plus 6. Is that greater than 0? So again, if we don't necessarily do the math, just sort of think it through, that is going to be positive, right? This is going to be negative, and this is going to be, negative, not negative 1, but a negative number. Negative times negative equals a positive. Positive over positive. Is that greater than 0? Yes, it is. So this gets shaded in. And I'm going to need to shrink that down so I can fit more work. Let's look at negative 6.5. Get the original problem in frame there. So negative 6 point, switch to blue, come on. Negative 6.5 plus 8 over negative 6.5 plus 7 times negative 6.5 plus 6. Is that greater than 0? Okay, so what's negative 6.5 plus 8? I don't know, 1.5 or whatever, but the point is it's positive. What's negative 6.5 plus 7? That's going to be another positive. And negative 6.5 plus 6, that's a negative. Is that greater than or equal to 0? Why would I put a negative 1 there? I don't know. Something's stuck in my brain. The fact is, it's just a negative. Right? Negative 6.5 plus 6 is a negative. So a positive times a negative equals a negative. Positive divided by a negative is a negative. Is a negative greater than 0? No. So that next section does not get shaded in. Hope this isn't too confusing. Makes perfect sense in my head. Okay, now for the next section, we're going to plug in negative 5. Negative 5 plus 8 over negative 5 plus 7 times negative 5 plus 6. Is that greater than 0? Negative 5 plus 8 is a positive number. Negative 5 plus 7 is a positive number. Negative 5 plus 6 is a positive number. Multiply and divide positives, you get positives. Is a positive number greater than 0? Yes, it is. So that gets shaded in. So our answer is the interval from negative 8 to negative 7 with parentheses, unioned with negative 6 to infinity. And that was a lot of work. Let's check and see if it's right. Where are we? Right here. Negative 7 to negative 8 to negative 7, negative 6 to infinity. Union. Good. 2 more and we're done. Okay, so before I do this one, I'm going to go ahead and factor. That'll make the work a little easier in the long run. So x and x, what multiplies to 21? 7 times 3. Negative 7 plus 3 is negative 4. So there we go. All right, discontinuities. Set the bottom equal to 0. You get x equals 4. So there's one critical number. Zeros, set the top equal to 0. And since the top is already factored, you just go x minus 7 equals 0, x plus 3 equals 0. Solve them both. X equals 7, x equals negative 3. So our number line diagram is going to have 3 critical numbers on it. Negative 3, positive 4, positive 7. Make sure you put those in order. You don't write down 4, 7, negative 3 on the number line in that order. That would be silly. Okay, oops. Now test numbers. Well, you know what? No, let's see. I do believe everything gets a circle, right? There's no equal sign on the top, and the bottom discontinuity always gets an open circle. All right, now test numbers. Negative 4. A number between negative 3 and 4 is 0. I always like to use 0. A number between 4 and 7, how about 5? And a number greater than 7, we'll go with 8. So you have to plug all those test numbers in to this. You might ask, could you plug it into the original? Yeah, you could, but it's easier. Oops, didn't mean to do that. It's easier when you just use the factored version, or I think it is. So here. Negative 4 minus 7, negative 4 plus 3, or negative 4 minus 4. Is that greater than 0? Let's see, what is that? That's a negative number, not negative 1. Why do I keep doing that? That is a negative number, and that is a negative number. 2 negatives make a positive. Positive divided by negative is a negative. Is a negative greater than 0? No. Let's take the next test number. Nope, let's shrink this, move it out of the way. Next test number is 0. 0 minus 7, 0 plus 3, 0 minus 4. Is that greater than 0? Well, that gives me a negative, a positive over a negative. Negative times positive on top is a negative. Negative over negative is positive. Is a positive greater than 0? Yes, it is. That gets shaded. Shrink that, move it out of the way. Let's try 5. 5 minus 7 over 5 plus 3 over 5 minus 4. Is that greater than 0? That's going to give me what? 5 minus 7 is a negative. 5 plus 3 is a positive. 5 minus 4 is a negative. Just doing a quick double check because I'm a little worried that I'm about to screw something up. Yeah, I did. Duh, 5 minus 4, is that a no, 5 minus 4 is positive 1, stupid. Okay, whew. Just got a bad vibe there and it paid off. All right, anyway, on top, negative times positive is negative. Negative divided by positive is negative. Is a negative greater than 0? No, it's not, so we don't color in that interval. Now let's do 8. 8 minus 7. 8 plus 3, I don't know what was wrong with that 8. 8 minus 4, is that greater than 0? That's going to give me a positive, and a positive. Positive times positive, positive divided by positive, yeah. Kind of rushing, but yeah, that works out. This interval is a good interval. So my answer is -3 to 4 unioned with 7 to infinity. Whenever I say to infinity, I do want to say and beyond, but I don't do it. All right, looks good. Last problem. Okay, a lot of space to work. We might need it. I don't know. So as with every problem, we need one side to be 0. So here's what I can do. I can rewrite this like so. Right? You just take this term and minus it to move it over to that side. Subtract it. If you don't like people who say minus it, subtract it. But now I need to combine these together. So what do I need to do? Well, I'm going to move this way out of the way. To give these common denominators, I'm going to need to multiply this one by x plus 3 over x plus 3. I need to multiply this one by x plus 2 over x plus 2. Right? So that gives me common denominators. Like I did on yesterday's work, the LCD is going to work out to be x plus 3, x plus 2. Unlike yesterday, stuff isn't going to cancel. So I can put this whole fraction all over x plus 3, x plus 2. Now I'm not going to FOIL this all together because we're going to want it factored, right? That's what I did on all these other problems, is factor them. So we can just leave this denominator like this. It's beautiful that way. For the numerator, so what do I have here? I have 4 times x plus 3 minus 3 times x plus 2. And make my 0 look more like a 0, not like a 6. All right. Distribute this in here. 4x plus 12. Distribute that -3 there. You get minus 3x minus 6 all over x plus 3, x plus 2. If I combine these like terms, what do I get? 4x minus 3x is x. 12 minus 6 is positive 6. Over x plus 3, x plus 2. All right. Now we've combined this all together. We have one side equal to 0. Discontinuities. Set the denominator equal to 0. Set each factor equal to 0. we get x equals negative 3, x equals negative 2. Then find the zeros by setting the top equal to 0. You get x equals negative 6. So we have three critical numbers. Our critical numbers are negative 3, negative 2, and negative 6. Let's go ahead and make a number line out of this. In order, negative 6 is the smallest, then negative 3, next to negative 2. Let's see, the discontinuities both get circles. The 0, there is an equal sign here, so that is going to get a dot. Now we pick test numbers. So how about negative 7, negative 4, negative 2.5, and, or wait, yeah, I forgot my negative sign there. And we'll go with 0 because I like 0. Now we're going to plug those into, not the original. I mean, you could, but if we plug it in right there, it's going to be a lot better. So negative 7 plus 6 over negative 7 plus 3, negative 7 plus 2. Is that greater than or equal to 0? Well, that's going to be what? A negative, and a negative. Two negatives make a positive. Negative divided by a positive equals a negative. Is that greater than or equal to 0? No, that's not greater than or equal to 0. Move on to the next interval. Negative 4. So negative 4 plus 6 over negative 4 plus 3 times negative 4 plus 2. Is that greater than or equal to 0? Negative 4 plus 6 is a positive number. Negative 4 plus 3 is a negative number. Negative 4 plus 2 is a negative number. Negative times negative equals a positive. Is a positive greater than 0? Yes. That gets shaded in. Let's take negative 2.5. Now, generally, working with decimals or fractions or whatever can be a pain, but here, the way we're analyzing this is just, is it positive or is it negative, and that makes it a lot easier. So negative 2.5 plus 6 over negative 2.5 plus 3 times negative 2.5 plus 2. Is that greater than or equal to 0? Negative 2.5 plus 6 is a positive number. Negative 2.5 plus 3 is a positive number. Negative 2.5 plus 2 is a negative number. That gives me a positive over a negative. Positive divided by negative is negative. Is a negative greater than or equal to 0? No. So we do not shade in that interval. Whoa, that was fun. Oh, come on. Get stuck like that. Okay. What the hey? Serious, guys, it's just getting away from me. What the heck here? Every time I let go, there we go. All right, I'm not going to tempt fate. We'll call that good enough. All right, good. Okay, now let's plug in 0. 0 plus 6 over 0 plus 0 plus 3 times 0 plus 2. Is that greater than or equal to 0? 0 plus 6 is positive. 0 plus 3 is positive. 0 plus 2 is positive. That gives me a whole bunch of positives. And a positive is greater than or equal to 0. So, shade here. So it looks like my answer is bracket negative 6 comma negative 3 parenthesis union parenthesis negative 2 comma infinity parenthesis. Let's see if that's right. If it's wrong, I don't know if I have what it takes to fix it. There it is. Good. Okay, hopefully this is stuff that makes sense to you and you can do. your problems kind of mirror my problems. I would just say it looks like on number 13 I didn't give you a ton of room to work, so I'm going to go ahead and try to shrink all of this to move it a little bit out of the way if you're the type of person who likes to use this paper. Okay, there it is. All right, I'm going to stop here. Please, please, please contact me if you have any questions. This is not the easiest stuff we've ever done, and we have a test right around the corner. All right, look forward to